Part 3 of algebraic expressions. This one's just focusing on factoring expressions. So let's say that I have 6b, which stands for 6 blue M&Ms, plus 4o, or orange M&Ms, 2y, or 2 yellow M&Ms, plus 5g, or 5 green M&Ms. Now, if I was trying to simplify this, there is a way to simplify that may not seem apparent at first. Is there anything, if I look at the coefficients here, if I look at 6, 4, 2, maybe not 5, but if I look at the first 3 terms here, is there any number that can go into 6, 4, and 2? Is there any factor? Is there a way I can factor anything out of 6, 4, and 2? Well, if you look at 6, 4, and 2 and you think, well, wait a minute, they're all multiples of 6. I can divide this by 6. I can divide this, I can divide this by 2. I can divide this by 2, and I can divide this by 2. Well, that's what we're going to end up doing. We're going to factor out 2. Okay? We're going to leave this alone. Okay? We're going to put this kind of by itself for now. We're going to just table that for now, if you will. We're going to take the 5 greens and just set them over here for a bit. Okay? And let's just focus on these 3 things that can be divided by 2. 6 can be divided by 2 into groups of 2, right? So if we divide that into groups of 2, we'll have 2 groups of 3. If we divide this by 2, we get 2 groups of 2. And if we divide this by 2, we got one yellow each. Okay? So what do you end up here? Well, now you've got 2 groups. So on the bottom here, I'm going to put 2 groups of 3 blues plus 2 oranges plus 1 yellow. Put that in parentheses. And that's basically what we're doing, is we're factoring it out. We're basically going backwards in what I would say would be like kind of like distributive property. So when we distribute the 2, it'd be 2 times 3b plus 2 times 2o plus 2 times 1y. But basically you're factoring out, you're basically dividing out. And then what do you have left? Well, we still have those 5 green, so there's really not much you can do except plus 5g at the very end. Okay, they're kind of on their own. So that's basically factoring out. So let's think of another example that maybe a little bit more theoretical and not so practical, kind of like the M&Ms. But if I had, let's go down to, let's say I have 6a plus 4b plus, let's come up with another one, let's say 10c. Okay? Let's say that was our expression, and we wanted to factor this. So to factor it, we would have to find the greatest common factor of 6, 4, and 10. Well, in this situation, it's still going to be 2, very similar to what we did up here. So we're going to have to divide each one by 2. So if you divide everything by 2, basically what you're doing is you're factoring it out, right? You're pulling it out. You're pulling out something that they all have in common. So when you factor it out, 2 comes out here. 2 times 3 is 6, right? So 2 times 3a is going to become 6a. Plus 4 divided by 2 is 2. And put b right here. So 2 times 2b is 4b. Plus 10 divided by 2 is 5. 5c. So 2 times 5c is 10c. So that's being factored out. Let me cross these out real quick so we don't get too confused. But basically, this algebraic expression being factored would look like this. Factoring that out. Okay? Maybe another way of looking at that real quick, because some people still have a hard time understanding what factors mean. So if you recall back to a factor tree, if we had split these all up to factors, give me 2 prime factors that create 6, and 4 and 10, well, 2 times 3 equals 6, 2 times 2 equals 4, and 2 times 5 equals 10. These are what we call factors, right? These are prime factors. You can't break down the 2, the 3, you can't break these down at all. They're prime. The only thing you can divide them by is 1, but that doesn't change anything. You can't really do that. So 2 and 3 are factors of 6, 2 and 2 are factors of 4, 2 and 5 are factors of 10. Well, what do they all have in common? Well, they all have a 2 and at least one 2 in common. So that's what you pull out. So when you pull that out, what do you have left? 3, 2, 5. 3, 2, 5. That's what you have out. So when you pull it out, you put it up front, then you put the variable along with what it stands for, because remember, 6a means 6 times a. Okay, we don't know what a is, we don't know what b is, we have no idea what c is, so we leave it alone. Okay, so this is just a good example of factoring out 2 in this situation. I'm going to do one more. Hopefully I haven't confused you at this point, but let's say, let's get something a little bit different here. Let's say 6p plus 12d. All right. If I was going to factor out of this expression, what could we actually divide out or factor out of 6 and 12? Well, some people might say, well, you can divide it by 2. And that's true. You could divide both of these by 2. So you could factor that out. So that would be 3p plus 6d. But the problem is, very similar to simplifying fractions, it's still not in its simplest form. You can still actually pull out that 3. You see, 3 can actually go to 3, and 3 can go to 6. So this is not really simplified. So 2 is basically too small of a number. Okay, so that's not going to really work out too well. Some of you might think, well, wait a minute, 3 can go into 6 and 3 can go into 12. That's true. 3 times 2p would be 6p. 3 times 4d would be 12d. 3 times 4d would be 12d, and that would work. The only problem is you can still pull out a 2 here and pull out because 2 times 1 equals 2, obviously, and 2 times 2 equals 4. So you can still pull out that 2 here. You can factor this out some more, so this is not going to work out well. So again, you want to think of what is the greatest common factor of 6, the greatest common factor of 12. What do they have in common with each other? Well, 6 can go into 6, 6 can go into 12. So pull out the 6. Instead of doing the 2 and 3 separately, pull out the 6. So 6 times p equals 6p plus 6 times 2 equals 12, and just put the variable right next to it, 2d. So 6 times p is 6p, and 6 times 2d is 12d. And so that's being factored out. So again, this is, if you want to simplify it a little bit further, you can factor it, and that's what it's going to turn out to be. Okay, so you're just basically grouping it. So there's 6 groups of p plus 2d. Basically what that looks like is you have p plus 2d, and you've got 6 of those. Okay? And, I mean, that's a lot. Let me see if I can write it all out here really quick. Keep my video as short as possible here. Okay, so basically you got 6 of those, right? Right, and if we were to add them all up, you know, there we go. If we add them all up, we end up with 1, 2, 3, 4, 5, 6, 6p plus 2, 4, 6, 8, 10, 12, 12d. And again, p and d could stand for, you know, puppies, and d could stand for dogs, you know. Or p could stand for 3, and d could stand for 4, you know. And so in this situation, you would just plug this in here. So 6 times 3 would be 18, plus 12 times d, in this case, could be 4. And you could actually solve it. But again, we don't know what the variables are at this point. These are just simplifying an expression, an algebraic expression that we're given, into a format that is utilizing distributive property. Okay, so this will be our answer for this. All right, hopefully that helped.